All right, the recording started, so welcome to the new material. Let's get started, and I should have had this open differently. All right, so we're going to talk about decimals and percents today is mostly what we're going to talk about. So week 3, can you believe you're at week 3 math, decimals and percents. Wowzers, that's good stuff. Decimals and percents. All right. So let's first talk about operations or math with decimals. And I'm gonna have to share this. I realized I'm gonna have to share my lesson plan to my phone, or else I won't be able to see it when I teach. So give me a second. I should have done that while we were on a break. Um, Decimals and percents. Now we're rock and rolling. I gotta stay me to get something. So when we want to do operations on decimals, the most important thing is to have everything lined up. So what do I mean by lined up? I mean, like, when you got the decimal, the decimal in the other part of the problem should be right in the same place that it is. Let's explain that with an actual problem, because I think that's the kind of thing that, like, when teachers do, it's confusing. So, for example, let's say we have 0.77 plus 14.6. Now, when we line this up to add, we can't do this, for example. We can't have the 0.77 over here. That won't work. There's a fraction jail I told you about. This would just send you to decimal jail. So instead, we have to say 14.6, and then we line up the decimal point, and then we have 0.77. Now we can add a 0 after the 6, because the zeros just continue on endlessly after when we're doing decimals. And then we can add. So we have 7, we have 13, bring up a 1, we have 5, 15. So 15.37 is the answer. That's pretty simple, right? That's not the worst thing you've had to do in your life. Let's look at a subtraction problem. I gotta unlock my phone, of course. So let's say 5.5 minus 0.41. So let's say 5.5, and then we got to 0.41. If we had done 5.5 minus 0.41, that would not have worked. So we can add a 0 here. We can say 10 minus 1 is 9. Bring this down to 4, 0, 5.09. Now let's do some multiplication. 0.7 times 0.03. So 0.70 times 0.03. Now let's go 0 times 3 is 0. 7 times 3 is 21, so bring the 2. Oh, 2. Placeholder 0. 0 times 0, 0 times 7. So we bring the 210 down. Then we have to count the decimal places. Pay attention to this and then go back and rewatch it on the recording on YouTube. We have 1, 2, 3, 4. So 1, 2, 3, 4. So our answer is 0.0210. Beautiful. Here's one, 77.5 divided by 25. Now here we put in our house, we put 77.5, and then out here we have 25. So how many times is 25 going to 77? 3 times, because 25 times 3 is 75. Bring the 75 down and subtract. We get a 2, we get a 25. 25 goes into 25 one time. Now this is the important part. We have to bring the decimal up right where it was, and then we get the answer is 3.1. Now that was easy because we didn't have a decimal out here. Now let's say we had a kind where we had 278 divided by 3.6. Excuse me. This one's a little harder. So 278 divided by 3.6. Now what we're going to do here is we're going to move this decimal over 1 here, and there's like an invisible decimal there because it's a whole number. We're going to move that over 1, so it means we get a 0. So I'm going to rewrite this. It's 36 into 2,780. Just like a rule of division, you cannot have a decimal out here. Cannot have a decimal out here. That's just a rule. Um, so now we can say 36 goes into 27. We don't know how many times. We have to guess how many times it goes into 278. Let's say 36 times, I don't know, 7. So that's 42. 4. 3 times 7 is 21. Plus 4 is 25. So 252. I think that's probably the right answer there. So 7, 252. 8 minus 2 is 6. 7 minus 5 is 2. 2 minus 2. So then we bring down the 0. Now, how many times does 7 go into 260? Well, we know it goes in 7 times because it's 252. So we get 10 minus 2 is 8. 5 is 0. 0. So we get 8. Now we got to add a decimal there and bring a 0 down. Actually, so we can do it. I'm trying to think we should do it that way. Yeah, let's do it this way. So 36 goes into 80. 36 times 2, 12, 1, 6, 7, 72. So it goes in 2 times. And then you'll get 8. And now we're going to have a pattern come up because we have 80 again. We're going to have 72. We're going to have 8, 2. So the 2's go on forever. So here's something to remember. If you ever have a situation where when you're dividing, it's one number is going to go on forever and ever, what you can do is instead of writing all these out, you can simply put a line over it. So you can say 77.2 with a line, and then that is sufficient. Other way we could have done this, we could have, instead of doing the 2, we could have just brought this 8 up here and said 8 over 36, which simplifies to, if we divide them both by 4, it simplifies to 2 over 9. So 77.2 with a line over it, or 77 and 2/9 would be your answer. All right. So those are 4 operations with decimals: addition, subtraction, multiplication, division. Now let's do fractions decimals. So now let's say you want to take a fraction and turn it into a decimal. Fraction to decimal. 3 over 16. Now all we need to do here is divide it. So we have 16 and we have 3, except I did it backwards. It's the other way. It's the other way. Let me get my pen. 16 into 3. Now we're going to have to add a decimal and add a 0 and say 16 goes into 30 one time. 16, 30 minus 16 is 14. then we're gonna have to add a 0 here and bring it down. 16 goes into 140. I don't know how many times. Let's guess 6 times. 6, 36. 6 times 1 is 3 is 96. Nope, that's not enough. Let's do 16 times 8. That's 48. 4, that's 128. That should be enough. Um, that should be enough there. So let's do an 8. 128. 10 minus 8 is 2. 2 is 0. 0. So then we bring a 2 down. Um, sorry, that should be a 12. So we bring a 0 down. Now, how many times does 16 go into 120? 16 times 7, 42. 7 times 1 is, or 7 times 1 is 7, plus 4 is 112. So I'm going to put a 7 up here. We're coming to the end of this one. I know this one's been going on for a while. That's 8. We bring a 0 down. 16 times 5, 0, 3, 80. So that's 80. So the answer is 0.1875. So to go from a fraction to decimal, you just do the math out. Now I've got one for you all to try. 9 over 25. Turn this to a decimal. And your hint, not hint, but like thing I want you to do is 9, or sorry, I'm going to give you the hint. You're going to set it up like this. So why don't you all try this? I'm going to give you a few minutes to try this, all right? I'm going to get my phone charger so my phone keeps quit shutting off while I'm working on the problems. When you want me to work it out, let me know. Put your answers in a private chat. So rock and roll, team. How are we doing? Or you just want me to give you time? Okay, I got a request to work it out. I can do that. I'm gonna give like 2 more minutes if anyone else wants to be working on it, just so y'all have a chance, but I will work it out. All right, I'm gonna work it, okay? So let's see, 9/25. First thing we need to do is add a decimal and add a 0. 25 goes into 9 how many times? 25 times 3 is 5, 1. Oh, sometimes that happens, I don't know why. I'm gonna start over. 25 times 3, 5, 1. 2 times 3 is 6, plus 1 is 7, so 75. So 3, 75. This is 10 minus 5 is 5. Turn that into 8 is 15. We'll bring a 0 down. So how many times does 25 go into 150? Say 25 times, I don't know, 6, 3. 5 times 6 is 30. 2 times 6 is 12, plus 3 is 15. 150, 0, sorry, 6. So the answer is 0.36. There we go. Let's look at our next problem. Let's look at going decimals to fractions. This is a funky thing. So let's say we want to go from a decimal to a fraction. So let's say we want to go from 0.75 and turn this to a fraction. Now you might know in your head that this is 3/4, which is good if you know that. It's good that you recognize it. But we need to work it out the long way. So we need to be able, so we're gonna, let's, yeah, let's work it out the long way. Um, so you'll be able to check your answer. So what we're gonna do is we're gonna say 0.75, we're gonna divide it by 1. This is something we're gonna do over and over. 3 divided by 1 equals 3. 4 divided by 1 equals 4. 16 divided by 1 equals 16. So if you divide anything by 1, it equals 0.75, the same thing. So 0.75 divided by 1 is 0.75. Now what we're going to do is we're going to multiply this by 1 in a kind of funny way. We're going to multiply it by 100 over 1. 100 over 100. Because in the same way, 3 over 3 equals 1. 4 over 4 equals 1. 16 over 16 equals 1. So in the same way, 100 over 100 equals 1. So this is the same thing as multiplying it by 1. And we know if we multiply something by 1, it doesn't change at all. It's just staying the same. So we're just keeping this the same thing, we're just making it look differently. So 0.75 times 100 is 75. 1 times 100 is 100. Now we have a fraction and we just have to simplify it. So 75 over 100. Let's divide each of these by 5. Well, 100 divided by 5 is 20. 75 divided by 5, I think it's 15. Let's see. 5, 2, 5 isn't 25, 5 times 15 over 20. I think that can simplify more, so let's take 15 over 20. Let's divide each of these by 5, and we get 3 over 4. And like I said at the start, you might recognize that's what it is, which is good. So that's fine. So let's talk about percents and percentages now. This is getting into the weeds here. Let's talk about percents. Separate it like that, percents. All right. So the symbol for percent is this. Let's do equals percent symbol. Now here's a question. It's not rhetorical, so answer. How long do you live if you live to 100? If you live 100 years, what do we call 100 years? What's another word for 100 years?
A century.
A century. Century. And that means 100 per century. Percent per 100. So when we're talking about percents, it's like a special kind of fraction that's out of 100. And you can think of that as living to 100 to remember that it's a century. So percents are measuring things out of 100. And we often use this a lot. If we're feeling really good, we might say, I feel 100%. If you're feeling like average, you might say you're at 50%. You might say your gas is at 30%. Maybe your car tells you that. You might say you scored a 90% on the test. When you're taking the ASVAB, you want to score the 31st percentile because that's what it means for you to be able to get into the Army. So it differs, based on different based on whatever you're measuring. But it's when you need to measure something between 0 and 1, you can use percents. And fractions and decimals are like this as well. We can say I ate 50% of the pizza. You could say 0.5 of the pizza, or you could say I ate 1/2 of the pizza. 1/2 sounds the most natural, but you could say anything. We just have ways of talking about certain things and certain things. Like you wouldn't say I scored a 9/10 on the test. You'd say I scored a 90% on the test. You wouldn't say I ate 50% of the pizza. You'd say I ate half of the pizza. That's just like we use different kind of phrases for different things. So percents are going to be really useful to think about. And sometimes what we're going to be asked to do is ask what percent something is a portion, percent of something a portion is, or what portion is a certain percent. So let's explain that. So let's look at this one. So let's say there are 100 people at the gym, and 50 are lifting. So I might ask, what percent are lifting? The answer is going to be 50% are lifting. Now you might also get asked, you might also say, I
The other
went into,
people. Oh, go ahead.
sorry, no, what were you going to say? Yeah.
I was about to say what the other 50 was it running or something?
Yeah, they'd be running. Maybe they're doing yoga. Maybe they're
Okay.
doing. I went to this one gym once where the cardio room was a movie theater. So maybe they're watching Up while they're doing cardio. Who knows? But 50% are lifting. You might also get asked a problem kind of like this. You might be told that I'm planting garden. You might know that Eli has a garden, which this is definitely not true, with 100 plants. And you might be told 20% are tomatoes. And then you might be asked, how many are tomatoes? Sorry, it takes me a while to write. And so the answer is 20. Now, I wish I had 100 plants. I wish I had 10 plants. My plants have not sprouted, and I'm really bothered by it. But I want you to notice there's two kinds of questions here. This first one, they ask you, they tell you how many are doing something, and then how many there are total, and they want to know the percent. This next one, they tell you how many total there are and what percent, they want to know what number. So there's like three things we're moving between. We're moving between the percent, we're moving between the total number. I'm going to use the hashtag sign for number. And then we're going to move between the portion, which is like the part or the fraction. So we're moving between really these, and we have to use this as our guide. All right. So here's what we have to do. Is we have to turn the fraction into a decimal and then the decimal into a percent. Wow. Let's do this. So we have to turn the fraction into a decimal and then the decimal into a percent. That's going to be the easiest way. So let's look at this first one. So remember we had 100 at the gym and we had 50 lifting. So, well, what can we do here? We can say there were 50 lifting over 100 total, and we can turn this into a decimal. How did we turn it into a decimal? We divide it. So we'd say 50, 100, or is it the other way? No, this is right. So then we have to do the decimal and a 0. 100 goes into 500 5 times. 500, 0, bring up the 5. So it's 0.5 is the decimal. And then we turn that to percent. How do we turn decimals into percent? Watch this. 0.5, then we multiply it by 100, and then we add a percent sign. So 0.5 times 100. There's two ways to do this. First, let's do 100.0 times 0.5. This is going to be annoying. 0, 0, 0, 0, 0. Add a. Actually, sorry, not all those zeros. Let me just erase those because we gotta do those things. 0, 0, 0, 5. Then we have 1, 2 decimal places. So 1, 2. So we have 50. So we have 50%. Now the other way to do that you're going to hopefully get comfortable with is you see you have this decimal. You can just go 1, 2. Add the decimal. There you go. 50. That's how you do. You can do decimals into percents, or decimals into percents, because you just multiply into 100. Let's do the other direction. Let's look at this other problem I did, the garden with tomatoes. So I said I had 100 plants, 20% tomatoes. Now we got to do this annoying thing. So 20%, we got to turn this to a decimal. We're going the other direction now. So to do that, we drop the decimal sign, and instead of, you remember when we had the 0.5, we did 1, 2, that direction. Now with the 20, we're going to do 1, 2, that direction. So we get 0.2. Now what we do is instead of divide, we multiply. So 100.0 times 0.2 is 0, 0, 0, 20, 1, 2, and why 2? Because 1, 2. So you have 20. So 20 plants are tomatoes. All right. let's work a more complicated problem. I'm gonna copy paste. Ooh, that looks gross. All right, let me make it bigger. All right, in a class of 40 students, 25 students did their homework. What percentage did not do their homework? So we have here 25 over 40 did their homework, but we're not interested in how many did. We're interested in how many did not do their homework. So if there were 40 students and 25 did their homework, 40 minus 25, 10 minus 5 is 5, 3 minus 2 is 1, is 15. So our fraction is 15 over 25. Now we have to turn this into a decimal. So 25 goes into 15, add the decimal. 25 goes into 150. We actually did this earlier. It goes in 6 times. That equals 150, 0, 0, 0. So our decimal is 0.60. Now we can go 0.6. Oh, we did this wrong, everyone. You know why we did it wrong? Because we did 15 over 25. Should be 15 over 40. Sorry. That was getting too easy. So it should be 15 over 40 because that was the original number. Sorry about that. So 40 goes into 15. At 0, 40 goes into 150. 40 times 3 is 120. 120. We'll get 30. We'll bring down a 0. 40 goes into 300. 40 times 7 is 280. Bring a 0 down. Or actually, we got to subtract 200. Then 40 goes into 200. 40 times 5, 0. It's 20, 200. So we bring that decimal up. So we have 0.375. So that's the answer. Or sorry, that's the decimal. So 0.375. Then to make that a percent, we go 1, 2. So 37.5, and then we add the percent. So that's the percent that did not do their homework. Let's do this problem now about sunscreen. All right. All right. A group of 60 friends go to the beach, 25% remembered sunscreen. How many remembered sunscreen? So 60 and 25%. Now we got to first turn this to a decimal. So we've got to say that is 0.25. Then we have to say 60 times 0.25. So I'm going to go 60.00, 0, 0, 0, 30, placeholder 0, 0, 0, 0, 0, 6. So 0, 0, 0, 0, 3, 6. Well, this doesn't seem right to me. Oh yeah. Wait. Give me a second. 0, 0, 0, 30. Actually, I did one too many zeros. That should be 9. I think. Wait, sorry, I'm gonna start this over. This is why it's. What did I say? Keep them lined up. I did not get them lined up, and now I am paying by having to do the problem over again. That's embarrassing. All right, 0, 0, 0. 6 times 5 is 30. Bring up a 3. Placeholder 0. 0, 0, 0. 2 times 6 is 12. There we go. Bring down a 1. 0, 0, 0, 0, 5, 1. Now we had 1, 2, 3, 4. So 1, 2, 3, 4. So the answer is 15. So 15 students did not bring sunscreen, or 15 students did remember sunscreen, which is not enough. Always wear sunscreen. It's very good for you. All right, now the next form thing we're going to do, this is possibly the most important thing in the classes. Well, not the class, like tonight's class. I'm going to percent change. I'm going to put a box around this. Yippee. And then do a formula. You need to memorize this, okay? Like you need to memorize this. So percent change. Percent change. You need to have this so memorized that if someone wakes you up in the middle of the night and you're scared, you start screaming this formula out because you know how important it is. And the way we do percent change is new minus old over old times 100%. So that means we take the new of whatever it is and we subtract the old one from it. And then we take the that and divide it by the old and we multiply it by 100%. Memorize this. Memorize. 3 exclamation marks and then a smiley face so you know we're still happy about it. Let's do a really simple one. Actually, first I'm going to make a note. If your percent change is negative, there is less. If it's positive, there is more. So let's first look at 200 to 500. So we're going to go from 200 to 500. And I want to know the percentage change. So we're going to take the new. The new one is 500. We're going to subtract the old one, 200. We're going to divide by 200. We're going to multiply by 100%. So we're going to say 500 minus 200 is 300, divided by 200. Now, one way you can divide this simply, which I'm going to do here for the sake of time, is you can get rid of these zeros. So 3 over 2 times 100%. Now you can divide this out. 3 goes into 2. 3 goes in. To 20. Wait. No, I got that backwards. Sorry. Let's do it like this. 1.3 over 2 is 1.5 times 100%. 1, 2. So 150%. Let's do another one. I want you to be able to do these quickly, like do them a lot. So 25 to 45. Oh, that was funky. So the new is 45. The old is 25 times 100%. So 45 minus 25 is 20 over 25 times 100%. So here we're going to want to put 20 here, 25 here, add a 0. 25 goes into 208 times 200, 0, 0. 25 goes into 0, 0 times, so 0.8. So 0.80 times 100%. We move the decimal place 2 places. So 1, 2, 80%. Beautiful. Let's do a word problem. All right, make it bigger. All right, Jan got a raise from $12 to $15. What is the percent change in her wages? So let's take our formula. New is 15, old is 12. That's funny, 12. Old is 12 times 100%. So we have 15 minus 12 is 3 over 12 times 100%. Now to make your life easier, you can simplify. That's 1 over 4 times 100%. Then we can do the math. We can do 4 to 1. 4 goes into 10 twice. It's 8, 2, 0. 4 goes into 25 times, so it's 0.25. To turn that into percent, we do the decimal place 2 places, add a percent, so 25% is the answer. One more problem. Now we're going to finally have a negative one. So 27 students are in the class. Some dropped out until 18 were left. What is the percent change in the number of students in the class? So now we have 18 minus 27 over 27 times 100%. My time signs are funny and ugly. So 18 minus 27 is negative 9 over 27 times 100%. So then we can say 27 goes into 9. We're gonna have to add a 0. 27 goes into 90. 27 times 3 is 1, 2, 6, 81. 81, it goes in 3 times. 9. 27 goes into 90 3 times. Now we're gonna start getting a situation where we're gonna get the same answer over and over, 90 and then 3s. So we can just say 3 endlessly. But actually, for the purpose of a percent, we want a lot of spaces. So let's say 0.333. Now let's go 1, 2. This one's repeating. So 33.3% repeating. And we got to remember this is a negative. I didn't include that there like I should have, but this is a negative because it's getting fewer. All right. I'm going to give you one more type of problem because we have 2 minutes left. So sometimes they're going to talk about discount. So the price of a motorcycle is $1,500. How much do you need to pay if you get a 10% discount? So say you're like cousins with the person who owns the store. So you get a 10% friends and family discount. How much do you need to pay if you get a 10% discount? So let's say 1,500, and we want to find what 10% of that is. So how can we do that? We can say 10% equals 0.10, and then we can multiply 1,500 times 0.10. We're going to have to add 2 of these. I'm actually not going to do the zeros. I'm just going to do 0.1. So 0, 0, 0, 5, 1. Then we're going to go, we have
Is it
1, 2.
100? Is it 150?
Yeah, it's going to be 150. So, but this is your discount. Your discount is $150. So they want to know how much you have to pay. So you'd have 1,500 minus 150, 0, 5, 4, 3, 1350. So you'd have to pay $1,350 if you want to, if after a 10% discount. So I guess theoretically you could say this is useful in your everyday life. So we're right at 30 minutes after 9 o'clock Eastern, 8:30 Central. Thanks for coming. Take a break now. I'm going to stop recording.